Welcome to 20-1s. If you are seeing this, I obviously didn't make it back in time. Hopefully you enjoy this video. Maybe you'll see me partway through. I don't know. Let's get on to it. So we are going to continue on with our notes here. So we're solving rational expressions. So now what we're going to do is solve more, but this time in kind of word equation or word sentences kind of form here. All right, so let's get into our notes. So on page, that was a bit far ahead here. So on page 24, I'm going to ask you a few questions here. So we're still in the rational expression stuff. So we got this one equation up here, this v is equal to d over t. So it's probably going to be useful for most of these questions. So let's get into it. So what we're going to need to do is, well, first of all, let's just kind of decode our question a little bit. So we have Jeremy here. He's biking 144 kilometers to his destination and 144 kilometers back. Okay, so look, we've got a D there, so that's good. But he bikes twice as fast there than he does coming back. Okay? And then it tells us something about a total time. Right? We just want to figure out how fast he's actually going. So I'm going to try to do all these questions algebraically. That's a goal, right? We're not just going to kind of guess, check, and revise and hopefully get it right. But we have some information here that's kind of missing, like how fast was he going there and how fast was he coming back? And how long did it take to do either one of those two things? Okay, but we do know that if we added those times together, we'd get 27 hours. So that's what I know so far. So I'm going to just write down what I kind of know. Right? So I know that if I take a time, let's call this time 1 and time 2, if I added them together, I'm going to get 27 hours. Right? So that's what I know based on that last line is total time is 27 hours. I also know that he bikes twice as fast there. So he's going fast, but then he slows down. So let's say there is 2. So say V2 is twice as fast. Or so V1 is there. Let's say that. Okay, so V1 is there. So that's faster than coming back. So it also says twice as fast. So that's going to be 2 times the other speed. So let's call that V2. So that's what we know so far. Also, we know the distances. We also know that the distance 1 is 144 and the distance 2 is 144 kilometers. Okay. So we're actually trying to find these V's here. How fast are they actually moving? We don't care about the times, but we do have to use some information up here. So what we're going to do here, and what I suggest to do for most of these questions, is kind of fill out a table of our givens and what we know. So I'm just going to write out a little table over here. It's going to have the same information in it. Okay, so let's say we got up there and back. All right. So we're going to create a little table. And most of the time I give you the table. Like in these notes I don't. Let's say if I had a question like this and a table would be beneficial, I'll give it to you. All right, so we're going to make this table 3 columns large, and this bottom column is going to be the total. Okay. Now we're only going to fill out sections of the total. There's some parts that I really don't care about, like what's the total distance. I know it's going to be 288. You're going to add the two numbers together. Then let's move my face a little bit smaller here. Come on, I don't want to do that. That's better. Okay. With distance, we have, let's go v and then t. So these are our variables that we have in this formula up here. So what I want to do is I want to fill in as much of this table as possible and just kind of think about what other parts I can fill in or how I would calculate those pieces. So I got 144. We put this in kilometers. We want to put the units in the top there. So 144. That's the kilometers there if you weren't paying attention. V, that's what we're trying to find. We're trying to find the rates in which they travel. So I'm going to call one of them X. let's say back is x, and there is 2x's. It kind of makes sense of what we had over here. Like if x is back, there was twice as fast as it. So we had the kind of same logic that we had here. So I put that in our table. The problem is I don't know the time, but I do know the total time. So I'm only going to fill in the 27 down here. I'm not going to do anything else with the other ones. These kind of scratch off. You only fill in this bottom column with the stuff they give you. Don't just kind of add in extra pieces where it's not needed. Okay, so now I have this table I got to fill out, and then the only information that I really can solve is pretty much this last line here where it says T1 plus T2. So if I added these two pieces together here, I'm going to get this 27 hours, right? Yeah, 27 hours. I should put a unit there. Put it down here. So when I add those two pieces together, I'm going to get 27. But I'm not going to say T1 and T2. What I'm going to do instead is say, how would I actually calculate those numbers? All right? So if I wanted to find time, I'm going to have to rearrange this equation up here. All right? So what I actually would do, I'm going to just rearrange it for d to start off with. So I'll get d by itself. So I'll just times both sides by t. It's like a rational expression. If I want to get rid of the denominator, I'm going to times it to both sides. So I'm going to times the t up. And then I'm going to get the t by itself here. So to get the t by itself, I'm going to divide the v to both sides. All right, so I get t is equal to v over, or sorry, d over v. Yeah, that's our formula. Okay, so what I'm going to do is I'm going to use that formula there to help us solve this. Oh, I'm going to face over here. So this formula is going to help us calculate the time. If I knew the speeds, I can calculate the times by taking the d divided by the speeds. But since I don't know them, I'm going to just write down how I would do it. I would go 144 divided by 2x. Okay? And you know what I'm trying to do is I'm trying to create a chart full of one variable. Like all the stuff that I have on this side over here, there's lots of variables. T1, T2, V1, V2. There's like 4 things we don't know. So I'm trying to create a formula or a table here that just has this one unknown. This one unknown, it just happens to be x. This one just happens to be twice as fast. And this is 144 over 2x. And this is going to be 144 over x. Okay. So this last column here is going to be the important one. I'm going to want to kind of add these two top numbers, and I know it has to equal 27. So that's what I'm going to write out. I'm going to write out my equation. I'm going to write out 144. Remember that the T1 plus T2 has to equal 127, or 27, sorry. So if I add these together, 144 over 2x plus x, or sorry, 144 over 2x plus 144 over x, I know this has to equal 27. So here we go. This is my equation we got to solve. We just have to solve for x. This is one thing. And then after that, we just have to find the two rates, the there and back. So x is going to solve the back. 2 times that would be the there. All right. So I'm going to solve for x here, but because it's in the denominator and there's a 2 here, what I'm going to do is I'm going to times everything. Okay, so I wonder if I can, no, I'll have to rewrite it. All right, just like we always do. I'm going to times everything by the denominators to get rid of them. So I'll put these in parentheses here. I'll put these in parentheses too. Okay. So I'm going to, first of all, I'm going to start by times it by 2x. I'll times everything by 2x, and then I'll just see what happens. Right? So if everything times by 2x, these 2x divided by 2x, they're gone, so that's nice. 2x divided by x, the x is gone, but it leaves the 2 behind. Okay, so that's okay. I think that's going to help us. So what do we have here? So we got 144 plus 288 is equal to 54x. I guess I could pull my calculator out there. All right, so we'll just keep on solving for x here. So we got, I'll group my like terms on the left side there. So I got 144 plus the 288. So we got 432. I'll just divide both sides by 54, something you don't really have to show. And I get 8. Well, that's nice. That's a nice number. Okay, so what is this 8? Well, this 8 is a speed. Okay, it's a rate. So it's going to be our distance divided by our time. So our distance was in kilometers. Our time is in hours. So this is 8 kilometers per hour. Pretty cool. Okay, so it asks us to solve for two things. It asks us to solve for the rates in which he travels, so the rates. So both of them. So I'm just going to write on the side here, just a little paraphrase here. There, he traveled 2 times that, so that means he's going to travel 16 kilometers per hour. And back, he just traveled X. So that's 8 kilometers per hour. So not concerned about sig digs. This is not a science class. It's exactly 8, exactly 16. So that goes. That's it. Cool. So let's see. So we're going to create our table. We're going to see what kind of formula we can create out of it. And then solve for X. I think most of these just start off the same way. Some of them, the reasoning of some of the things is a little bit harder. So I'm going to start by creating our little table here. Well, actually, first I should ask. Let's see what he's doing. So Jim walks 12 kilometers. Then he bikes 5 times as fast for another 100 kilometers. Okay. The total time for the trip was 8 hours. Oh, so it's pretty much the same. Let's start it off. So we got walking. Okay, walking. Then we got biking. There we go. We got V, we got D, and then we got T. Now, the table doesn't really matter which order those variables are. Just making sure that we fill in the key pieces here. All right. That's my table. I still do. I have that total on the bottom here. So the total. Remember, you only fill in the piece that they give you. So I know like his total distance each one. Yeah, I think I changed the order of this from last one. Yeah, I did. I know his total distance is 112 kilometers, but they didn't tell me that. Right? I had to do that math myself, so I'm just going to leave that line alone. I'm just going to put in the 12 kilometers. I'll put my units on the top here. What's time in? Time is in hours. Let's put hours there. Okay. So we got 12 kilometers, and then we got 100 kilometers here. Time, the only thing I know about time is my total time. They told me it was 8 hours, so I'm just going to put down 8 hours in the bottom here. So I know the total time of his trip was 8 hours. That means I'm going to be adding these two things together, and I should be getting 8. All right, so over here are V. Remember, I'm trying to create this table using just one single variable. So I want to relate the speeds to each other. And it says here it biked 5 times faster. So you know the biking was 5 times faster than whatever walking happens to be. So walking, let's just call that X. So this is 5 times X. Cool. All right, using our same logic, we got the formulas at the top there. Most of the time I give you these formulas, so you don't have to remember them. But it's D over V. So I'm going to take the 12, going to divide it by X. I'm going to take the 100 divided by 5x, and I know if I add those two things together, I get 8. All right, so I'll move my head over sideways here. I'll set my formula up. So 12 over x. I'm going to add 100 over 5x. So those are my 2 times. It's like time plus time. I know it's going to be equal to 8. All right, so that's what we have so far, and then we're just going to follow that same logic we just did last time. I'm going to times everything by 5 and x. And I'm going to see what happens. So when I times everything by 5 and x, the 5x here cancels out. And that's in brackets there. Just the x cancels out here. So I got 5 times that's 60 then. 5 times 12 is 60. Yeah, that's right. Plus 100 is equal to 40x. All right, so let's add those together. So we got 160 is equal to 40x. Divide both sides by 40, and I get 4. All right. So what does x represent? So we have to kind of go back. It says we have to find his walking and biking rates. Remember, we put x in the walking speed part here. So whatever x is. That's his walking speed. So I'll just write that down here. Walk, we'll call it speed here. So it's 4 kilometers per hour because we use kilometers and hours here. And his biking speed is going to be, I'll just move my head sideways, 5 times that. That's how fast it's going. So 5 times 4 is 20. And there we go. Awesome. That wasn't too bad. All right. So this little table is kind of useful. Let's see. So here we got Sheldon and Simon. They leave Red Deer in opposite directions. Simon's just going a little bit faster, 18 kilometers per hour faster. And then in 6 hours, they're 1,000 kilometers apart from each other because they're going in perfectly opposite directions from each other. So let's create a little table here. So with Sheldon, we got Simon. We got V, we got D, we got T. That's a little bit taller. Cool. All right. So Sheldon, they leave in the same. In 6 hours, they're 1,000 kilometers apart. So that's going to be because they're traveling at different distances. But that total, that is 1,000 kilometers. That's going to be my total distance that I traveled here. So if I add these distances together here, I'm going to get this number 1,000 at the end. Okay, so let's see how we can relate everything together here. So it says Simon is going 18 kilometers faster, not 18 times faster, just 18 kilometers per hour faster. So if X was going, or Sheldon was going X, then Simon would be going 8 or X plus 18. Because 18 faster kilometers per hour. So Sheldon was going 100, Simon was going 118. Okay, so time. How are we going to incorporate time here? So it's 6 hours. So that's not a total 6 hours. That's just in 6 hours. Not like we add the 2 times together. They traveled at the same time. Oh, that means that time, that's in hours, is the same for both of them. Oh, that's convenient. Okay, that's nice. So what do we know? So let's D. So the D plus the D. Remember, I don't want to add in like D1 plus D2. And I don't know how far they are. That's what we're trying to find, the distance they each travel. I'm just going to go up here. Oh, D is V times T. So V and a T. Okay, so that means D here, if we're going X kilometers per hour and I travel for 6 hours, means this is 6X. Okay, and then this one would be 6 times X plus 18. Okay, so let's put that over here. So let's say we have these two distances. So if I take the distance of Simon plus the distance of Sheldon, it's going to end up being 1,000 kilometers. So Sheldon is 6x. Simon is 6 times x plus 8, because that's how fast he was going, x plus 18 times the 6 hours. That's got to be equal to 1,000. Okay, so let's distribute this in. See what happens. We've got 6x plus 6x plus, it's a bit too late. Actually, I'm thinking right now how late it is. The alarm might go off. I might have to stop this video and run. All right, 108, 1,000. Okay. All right, that's not too bad. It wasn't even a rational expression. I didn't have like times both sides by anything. I just kind of distributed my brackets out there and group my like terms. So we've got 12x. I'm going to minus this 108 over to the other side. So 1,000 minus that 108. 892. And then I'll just divide by this 12. Okay, let's do that. Divide by the 12. 74. Oh. 74.3 kilometers per hour. I'm just not too concerned about sig digs here. Just don't put too many. Okay. I should probably change that 7 to actually look like a 7. There we go. Let's see what I have here. There we go. So this one here is the Sheldon one, right? So this is X is in the Sheldon spot, so that's Sheldon. So how fast is Simon going? Or do I actually need to know that? We want to know how the distance they traveled. Actually, I'll write down both. I'll write down. So we've got Simon is going to be 18 kilometers per hour faster. So I'm just going to add 18 to this number. So Simon's actually going 92.3 kilometers per hour. Oh, we got the right answers there. Cool. Okay, it didn't ask that. It asked for find the distance they travel. Okay, so let's just write that in this little bubble right over here. I'm going to create a little bubble. All right. So Sheldon's distance is 6 hours times his speed. Okay, so I'm just going to do that. So I got the 74.33333. Going to times it by 6. So Sheldon traveled 446 kilometers. Okay, that's not bad. And I can use the 1,000 logic to find it, or I could just use his speed. So I'll take the 92 there and times it by 6. So I get Simon, who's going a little bit faster, is going to go 554 kilometers. Now, if I did add those together, look at that. You don't see it. 1,000 backwards. There you go. Perfect. So remember, all I'm doing in these two steps here is I'm just taking d is equal to v times t, right? So taking the velocity that we have here, these velocities here, the speeds, and times them by the 6 hours. Cool. All right, so let's see what happens in this next one here. We got John, he's going from A to B in 10 hours, and then B to A in 8 hours, so he's going there and back pretty much. The rate going there was 15 kilometers per hour more than, oh, so the rate coming back, so it's 15 kilometers per hour more than going there. So he's going faster going back. How far apart are they? How far is A from B? Oh, that's a weird question. It seems like we have less information. Let me just write down some stuff here. We got A to B, and then B to A. So let's kind of fill out our table. Our V, D, and T table here. What do we know? Okay, so we know that coming back, so B to A, was 15 kilometers more. So that's plus 15 more than whatever A to B was. So let's just call that X for now. So that one's X plus 15. We know that T, we know some numbers for T, so this is 10 hours. Let's put the units at the top here. And this was 8 hours. That's all we know. They didn't give us any totals. I'm not going to put 18 down there because that's not going to help us. So what else do we know here? B to A to B. So wouldn't that mean if we're going A to B and B to A, would that just mean that they're the same distance? So that these two things, I'm not just going to add them. I'm just going to say that they're equal to each other. Like if I say that is equal to the other one. I think that's all it is, isn't it? They're just equal to each other. Remember D is just V times T. So 10, this would be 10x, and this would be 8 times x plus 15. I just know that they're going to be equal to each other. So I'm just going to say 10x is equal to 8 times x plus 15. Okay, this is actually a pretty easy question to solve. Let's see. Distribute the 8 in. That's 8x plus some number. 120. There you go. Just kind of rearrange it. There's no squares or anything, so kind of lucky out so far. There's no squares. So I'll just minus that 8x over. So 2x. So 120. X is equal to 60. Yeah. 60 what though? This is x. X is in this right here, so that's x. That's a speed, so this must be, whatever these units happen to be, kilometers per hour. So it's going to be kilometers per hour. Okay, they didn't ask for that. It asked for the distance. Okay, so my answer is going to be over here somewhere. So we got the distance. The distance is going to be 10 times that because it's 10x. So I'm going to do a little comparison to make sure that it actually ends up being the same. So 10 times 60 is going to be 600 kilometers. So that's going to be an answer. But I want to double check. 8 times. So I'm just going to put down here just 1 second. X plus 15. That's 75. Yeah. Is 8 times 75? Because that's what the other one is. 8 times 75. Is that the same? Yeah, it's also 600. So that's good. Do a little verification. Awesome. Okay, so sometimes they're equal to each other. Okay, not bad. Let's see. Let's see what the next one's about. Sarah here is walked 10 kilometers into the country, and they returned a little bit slower. Maybe they got tired or something. 3 kilometers per hour slower. The total time for the trip was 7 hours. How fast did she walk going out of the country? Going out to the country. Out of the country. Let's just find both. I know the wording is a bit weird here. So let's fill out our trim. So we're going to say, I'm going to call this into, and I'm going to call this return. All right? Gotta make the sound effects. So I draw the table. So we have V, we got D, we got T. 10 kilometers into the country, and then she walked back. So I'm assuming that she's going to walk 10 kilometers back, unless she, for some reason, it doesn't make it out. That'd be weird if she doesn't. So I'm going to say those are the same. So these are in kilometers here. This is going to be in hours. This is the total time. So I'm going to put that down at the bottom here in our total column. Notice the last one we actually didn't create one because we didn't have one. I'll put it down here in the 7. So that means if I add these together, I'm going to be ending up with this, right? So I'm going to add these 2 times. I'm going to get this 7. What else do we know? Oh, slower. So she returned slower. So that means minus 3 kilometers per hour. So into was x, return would be x minus 3. This looks very familiar like the first question. We have these 2 times. They're going to add up to get this bottom one. So we have to figure out how to calculate time. So if I go back here, time is d over v. Okay, so let's go down. So time is d over v. So I got a d divided by x is my one here. And then d divided by x minus 3. But the d happened to be 10 here. So if I add those 2 times together, 10 over x plus 10 over x minus 3. I'll just put those in parentheses right now. Remember, this is just time. I'm going to add another time. I know this is going to have to be 7 hours. So I'm going to go to 7. Okay, I'm going to write it a little bit bigger because I'm going to have to do some manipulations here. Like we solved these before. We know what to do. So I'm just going to put that over x, give myself a little bit more space. Get this over x minus 3. Give myself a little bit more space there too. And then we'll just start multiplying up these denominators. Like, how do we get rid of divide by x? Well, times everything by x. Put these in parentheses too. Times that by x. Okay, so that's going to get rid of this x. That's awesome. Oh, but I still have this x minus 3, so that means I'm going to times everything by x minus 3. And hope I don't run out of space there. X minus 3. So this cancels out with that one. Okay, no more denominators. That's awesome. So let's just write out what we have. So I got 10 times x minus 3 plus 10x, okay, is equal to 7x times x minus 3. All right, so I'm just going to start multiplying things out, just like we did in previous questions, and solve for x. Let's see what we have. We got 10x minus 30 plus another 10x. And over here we got 7x squared minus 21x. Now, we have a quadratic. How do we solve a quadratic? Make it equal to 0. So this side has the x squared on it, so I'm just going to plop everything over to the other side over there. So let's see, we got I could have grouped these guys together and got 20, then minus it over, but it doesn't matter. So I'm going to get negative 41x here, and I got a plus 30. There we go, cool. And I'm going to look at that and say, can I factor this? Okay, so I can't take a 7 out of everything. 41 is not divisible by 7. But can I factor it? So I'm just going to double check something here. Ooh, it is factorable. Now, how I figure if it's factorable is I find the discriminant out. Like if I was going to use the quadratic formula, somewhere over there, I don't know which side of the board would be on. You find the discriminant, and it ends up being a nice perfect square, which it does. When I take the square root, I get 29 of that discriminant. Then it must have been factorable. So let's go through the factoring steps. So 30 times 7, that's 210. What multiplies up to 210? Well, that's a 210. And adds to 41. So I'm just going to say divided by 2. Nope, that's not right. 210 divided by 5. Nope. 210 not divided by 4. Divided by 3? No. 210 divided by 6? Yeah, 210 divided by 6. So 6 and 35, but they're both negative, because two negatives will make this positive, because it's got to add to a negative. That adds to negative 41. Sweet. So we got 7x minus 6, and then 7x minus 35. I notice I can divide these by 7. So remember, this is all on the side here. That's like off to the side. So my final answer over here is going to be 7x minus 6 and x minus 5. Is that right? 7x minus 5? Yeah. Cool. Now, we're going to have two answers here. This is kind of weird. But remember, when we talk about real-world questions, we always have to kind of be cautious of just writing down blindly what the answers are. Like sometimes if we get a negative number, it doesn't make any sense for speeds and stuff, or distances. Or in this case, if I were to try to find the return speed, how fast they return back, because going in, they're both positive speeds, that makes sense. Okay, so they're both in like kilometers per hour, going pretty slow, going like the 7 or 6 over 7 is going pretty slow. But when I say the return, so if I say like x minus 3 and I kind of match these up, what's 7 over 6 minus 3? Or 6 over 7, sorry, minus 3. Well, it's a negative number. It's going to be negative 2 point something. Or I put it as a fraction. Negative like 15 or something. But I'm not too concerned about that. I'm just like, I'm concerned about the fact that it's negative. Right? Why would it be negative? Why would it be like walking backwards outwards? Wouldn't it be walking further in? But this one makes more sense. If I minus 3 from this, I get 2 kilometers per hour. So it just makes more sense. Like remember, this is the into, and this is the return. Return. That makes more sense that these are going to be my answers. Cool. Yeah, there we go. So what we're going to do, I'm going to pause it there for now, and I'm going to hand out, or again, whoever is here, hand out the rational expressions and equations assignment. I'm just going to give you a little bit more time today. I'm going to give you a half hour or so, or a little bit more than a half hour, to kind of work through some of these practice questions here. This assignment, it's on the desk here. It has some word questions, and it does have, I think, a word question. Oh, it doesn't have a word question that pertains to like this total parts here. I'll talk about that tomorrow. And there's more practice questions in here that we'll do tomorrow as well regarding this stuff. So I'll see you all tomorrow. Bye.